Welcome to The Explainer. Today, we're talking about AI, but probably not in the way you're used to. We're going to peel back that sleek digital curtain and take a hard look at its real-world environmental price tag. And trust me, it gets pretty messy.
All right, so let's just jump right in with the big question that's going to frame everything we talk about today. When you look past all the code and the fancy algorithms, what's the real cost? I mean, the cost to our planet of creating and running one of these powerful AI models.
Okay, so get ready for this number. A pretty big study out of the University of Massachusetts Amherst basically dropped a bombshell. They found that training just one large AI model can pump out over 284,000 kilograms of carbon dioxide. Now, that is a massive number, right? Nearly 300 tons. But what does that even mean in the real world?
So let's start to break that down. We tend to think of AI as this intangible thing that just happens up in the cloud. But the reality is, every single query, every question we ask, has a massive physical and resource-heavy footprint right here on the ground.
And to really put that into perspective, think about this. It's the same carbon footprint as building and driving 5 cars for their entire lives. Let that sink in for a second. All of that environmental damage for just a single AI training run.
Okay, so let's dig in and figure out exactly where all these environmental costs are coming from. It's really a whole chain that starts with the energy it eats up and ends with the waste it leaves behind.
And this chart, wow, this really shows you that bigger is better mindset in action. Just look at the bar for GPT-3 all the way on the left. It absolutely towers over the others. We're talking 544 metric tons of CO2. Now compare that to an earlier model like BERT. It's an insane exponential jump. It just goes to show how much the carbon cost has ballooned as these models have gotten bigger and bigger.
And look, this isn't just about training the models. The day-to-day use is incredibly energy hungry. Every single time you ask a generative AI a question, it's using almost 10 times the electricity of a simple Google search. Now think about how many queries are happening every second across the globe. It adds up unbelievably fast.
But the cost isn't just about energy. It's also about the physical hardware. The chips and batteries that make AI possible rely on mining for rare minerals. And as this quote highlights, over 70% of the world's cobalt, which is absolutely essential for this tech, comes from just one single country.
In that extraction process, well, it comes with some truly devastating consequences. We're talking about massive deforestation, soil being completely degraded, and water sources getting poisoned with toxic chemicals. And then there's the human rights side. I mean, it's horrific. We're talking about the exploitation of at least 25,000 child miners working in incredibly dangerous conditions.
So what happens at the end of that hardware's life? Which, by the way, happens really fast with the pace of AI development. Well, this graph shows you the grim result. The constant demand for newer, more powerful chips is fueling this literal mountain of toxic electronic waste, and it's projected to hit nearly 75 million metric tons by 2030. That's just staggering.
Okay, this brings us to a really crucial twist in the story. Because this burden, all the environmental damage, the resource depletion, the human cost, it is not shared equally around the world, not even close.
Scholars have actually given this a name: necroexportation. So, what does that mean? Well, it's basically a modern form of colonialism. All the life-enhancing benefits of AI, the wealth, the convenience, that gets concentrated in the global north. Meanwhile, all the life-threatening costs, the harm, the exploitation, are systematically exported to the global south.
And you can see this imbalance so clearly on this map of the compute divide. The immense computing power you need to build and train advanced AI is almost exclusively located in just a handful of wealthy nations. This creates these vast compute deserts all across the global south.
This inequality extends to the hidden human workforce that makes AI possible. These are the so-called ghost workers who label data and moderate content. And just look at the wage disparity here. It's stark. A worker in the US might make 10, maybe 20 times more than their counterpart in Venezuela for doing the exact same essential work.
And the human cost here is just staggering. In a recent open letter, Kenyan AI workers, these are people who spend all day filtering the most traumatic content imaginable for pennies an hour with basically no mental health support. They describe their working conditions as being like modern-day slavery.
So, with the whole problem laid bare, the critical question becomes, can we fix this? What's actually being done to try and build a more sustainable and maybe more equitable future for AI?
Well, the first and maybe the biggest hurdle is just measurement. You know the saying, you can't fix what you can't measure? Right now, there aren't any standardized, transparent ways to measure AI's environmental footprint. Most of what we know actually relies on estimates and best guesses, not hard data.
This diagram really shows you why it's so complex. It's not just about the direct emissions from the data center itself, that's what they call Scope 1. You also have to account for Scope 2, which is the emissions from the power plant creating the electricity. But the really tricky part is Scope 3. That's the massive, often hidden emissions from the entire supply chain, from mining minerals to shipping the final product.
So in response, there's a movement called Green AI that's starting to gain some real traction. It's pushing for a new approach based on 4 key principles. First, efficiency. Let's design smaller, smarter models. Second, measurement. Let's actually use tools to track the carbon footprint. Third, transparency. Companies need to report their energy use. And finally, accessibility. Let's make sure these sustainable tools are available to everyone, not just a select few.
Really, what all this points to is a fundamental culture shift that's needed in the world of AI development. It's about moving away from this relentless bigger is better mindset and instead prioritizing smarter is better, building systems that are more efficient and ultimately way more sustainable.
And that leaves us with one last, pretty provocative thought. AI promises a better future. We hear it all the time. But as we continue to build this incredibly powerful technology, we have to keep asking ourselves, a better future? For whom? And at what cost?